Good day everyone, I am Jason John D. Paulo, and in today's presentation, I'm going to discuss my topic that is all about coal and the formation of coal. First, let me ask you, what is coal? So a coal is a combustible block or brownish block sedimentary rock with a high amount of carbon and hydrocarbons. A coal is classified as non-renewable energy source because it takes millions of years to form. And in 1698, when the steam engine was first invented, it was coal that fueled it. Coal has been a major source of fuel for humankind for hundreds and thousands of years now. This carbon-rich primary fossil fuel has powered the human civilization right from the time it was known.
What is coal? Coal is a fossil fuel that formed from the remains of plants that died millions of years ago. It is a non-renewable resource. Coal is a combustible dark-colored rock that can be ignited and burned to produce energy. 41% of all electricity is produced by coal. It is the world's largest source of energy used for the production of electricity. In coal-burning power plants, steam from boiling water spins turbines and generators to create electricity. Coal was formed from dead plant matter that fell into swampy water. It formed a thick layer of decomposing plant material called peat. To become coal, the peat must be buried by sediment. The continued burial and combination of heat, time, and pressure cause the complex hydrocarbon compounds in the peat to break down and change. Coal goes through different phases of carbonization over millions of years and can be found at all stages of development in different parts of the world.
Next, we have the formation of coal. Dates back to millions of years ago when the earth was covered only with a vast moist forest, having a huge trees, shrubs, ferns, etc. The formation of coal begins in the waterlogged environment, swamps and bogs where plant debris accumulated. The bacterial decay rate is reduced because the available oxygen in the organic rich water is completely used up by the decaying process. In this process or phases are called aerobic decay, anaerobic decay, and bituminization. In anaerobic decay or decomposition, living organisms which use oxygen feed upon the organic matter. They use nitrogen, phosphorus, some of the carbon, and other required nutrients. Much of the carbon serves as the source of energy for the organisms and is burned up and respired as carbon dioxide. Since carbon dioxide serves both as a source of energy and as an element in the cell protoplasm, much more carbon than nitrogen is needed. Next, we have the anaerobic decay or decomposition. It takes place in nature, as in the decomposition of the organic mads at the bottom of the marshes and its buried organic materials to which oxygen does not have access. Intensive reduction of organic matter by putrefaction. It is usually accompanied by disagreeable odors of hydrogen, sulfide, and reduced organic compounds which contain sulfur, such as mercaptans. In the last phase, we have the bituminization. The transformation of organic matters into bitumen as the conversion of wood by natural processes into several varieties of coal. After the bacterial decay stages, the peat must be buried under thousands of feet of sediment that provides an insulting blanket, trapping the natural heat rising to the surface. Once the temperature reaches 100 degrees Celsius, the bituminization process begins. Chemical reactions drives off water, oxygen, and hydrogen, which raises the percentage of carbon. And now, let's move on to the types of coal. These are lignite, anthracite, bituminous, and subbituminous. So first, we have the lignite. A lignite contains 25 to 35% carbon and has the lowest energy content of all coal ranks. Lignite coal deposits tend to be relatively young and are not subjected to extreme heat or pressure. Lignite is crumbly and has the high moisture content, which contributes to its low heating value. Lignite is mostly used to generate electricity. And next, we have the anthracite. Anthracite contains 86 to 97% carbon and generally has the highest heating value of all ranks of coal. Anthracite accounted for less than 1% of the coal mined in the United States in 2019. Of all the anthracite mines in the United States are in northeastern Pennsylvania. In the United States, anthracite is mainly used by the metals industry. And the third, we have the bituminous. Bituminous coal contains 45 to 86% carbon. Bituminous coal in the United States is between 100 million and 300 million years old. Bituminous coal is the most abundant rank of coal found in the United States and is accounted for about 48% of total U.S. coal production in 2019. Bituminous coal is used to generate electricity and is an important fuel and raw material for making coking coal or used in the iron and steel industry. And bituminous coal was produced in at least 19 states in 2019, but 5 states accounted for about 75% of total bituminous production. And the last type of coal, we have the subbituminous. Subbituminous coal typically contains 35 to 45 carbon and it has the lowest heating value than bituminous coal. Most subbituminous coal in the United States is at least 100 million years old. About 44% of total U.S. coal production in 2019 was subbituminous, and it's about 88% was produced in Wyoming and 9% in Montana. The remainder of the subbituminous coal was produced in Alaska, Colorado, and New Mexico.
Coal is classified into 4 main types depending on the amount and types of carbon it contains and the amount of heat energy it can produce. Lignite is the lower rank of coal with the lowest energy content. Then, subbituminous coal that contains 35 to 45% carbon. Bituminous coal contains 45 to 86% carbon and was formed under high heat and pressure. Then, anthracite. Anthracite contains 86 to 97% carbon and has a heating value slightly higher than bituminous coal. One way we get coal from the earth is underground mining, where shafts and tunnels are dug down to coal seams. Miners are then transported down the shafts to run machines that dig out the coal. Once the coal is dug out, conveyors bring the coal to the surface. Some coal is dug out from surface mines, also called strip mines. These are large holes and can be up to hundreds of meters deep in order to get the coal. Once the dirt is removed, equipment is used to remove the coal. The coal is often washed at the mine to remove impurities before it is transported to the power plants and other places that use it. Coal mining and the subsequent burning of coal can have many negative effects on both humans and the environment. The burning of coal emits carbon dioxide, sulfur dioxide, nitrogen oxide, and mercury compounds that pollute the air. The mining and burning of coal typically requires the use of water. Pollutants build up in the water used, contaminating bodies of water. Land resources are affected by coal mining and processing too. We've seen that surface mining disturbs large areas of land, while the soil at coal-fired power plant sites can also become contaminated with various pollutants from the coal. coal is an important energy resource, and new technologies are being created to protect human health and the environmental impact of coal energy generation.
And now let me ask you this. How coal was formed? We all know that a coal is a solid black, readily combustible fossil fuel that contains a large amount of carbon-based materials, approximately 50% of its weight. The formation of coal takes a significant amount of the first coal-bearing rock units appeared about 290 to 360 million years ago, at the time known as the Carboniferous or coal-bearing period. As well, there are extensive coal deposits from the Cretaceous age, that is about 65 to 144 million years ago. The formation of coal begins in areas of swampy wetlands where groundwater is near or slightly above the topsoil. Because of this, the flora present produces organic matter quickly, faster in fact than it can be decomposed. In these areas, layers of organic matter are accumulated and then buried. It is these layers of organic materials that then form coal. The energy in coal initially comes from the sun, and this energy from sunlight trapped by dead plants. And that's all for my report. I am JC John D. Paulo, student 19, and I hope you learned something from my report. Thank you.